one of the experimental approach which we try to adopt in body area networks, more specifically in mobile health. And my name is Hassan, and I'm from School of Computer Science and Engineering, National University, South Korea. And I'm doing my PhD integrated with my master's course. Well, the agenda of my presentation will be that I'm going to give you some introduction which we already know, but I'm going to have that session, and then we will talk about a little bit about the research and development, but what are the spaces between these two things. And then we will a little bit talk about the protocol which we try to implement, and then what kind of hardware devices we used to perform that small experiment. And then I'm going to show you the experimental clip which will show the demonstration of our software which we actually made. And then we can talk about future work and just discuss the conclusion work. Okay, so we are talking about body area networks. We already know that in body area networks we have different variable devices that can be a sensor, that can be like a thermometer or anything which we can wear. And of course, in order to reduce, why we need technology is just to reduce the efforts of human beings, right? Just to make comfortable and to get the accuracy and other things. So for this, we already have this very old concept of body area networks. And there are a couple of decades we have a strong research on that. Then we have body sensor units for numerous applications. More specifically, if we go into the deep, so we know that in body area networks we have sensors basically. And then whenever we talk about sensors, it means we are talking about something about networks as well. So, and then we have applications of those sensors or those body areas which can be healthcare domain, like continuous monitoring. For example, if there is a thermometer with a patient and we need the temperature after every 5 minutes to monitor, and it depends on the condition of a patient. So we can have a continuous monitoring system as well, which will be accurate, which will be in proper time, and which will give us the accurate value. And it depends on the parameters of the patient, how the patient is. And then in the end, I am saying that there is intensive research, but less deployment. Unfortunately, in almost every conference relevant to body area network, we have a lot of papers, and there are a lot of good publications in journals as well. But are they deployed actually? This is a question. Of course, they cannot be because it takes some time. So today, the main reason of this paper is to show some potential efforts towards the deployment of any protocol. Even though we try to simulate, we use different simulators, but those simulators cannot give us the output for which we were talking, or we write some papers, right? Well, more further, we talk about the M-health or E-health. So mobile health, what is mobile health? Or why do we need it? It's a mobile health system, healthcare system, that uses the information and communication technologies to automate and ensure the healthcare services to the patients at any time, anywhere. So this is a kind of definition which we can easily get from all the papers or all the manuscripts. And then what are the major components which should be involved in order to make a complete concept of mobile health? We have body sensors, as I told you in the previous slide, or devices that monitor patients' vital signs. Vital sign means if there's a patient in intensive care unit for some heart disease or something, diagnosis for the heart disease, so of course at least we need the heart beat rate continuously, what's going on in there. So it depends, it's not about only the body sensors, it is something else as well. Communication systems and protocols, for example, IEEE has a almost control on every protocol, so they are actually a standardized organization, we know that. So they have already completed one protocol, but still the complete implementation of that protocol is still in progress. And then we have healthcare service providers. Where do we need M-health? In our homes, in shops, in petrol pumps or in somewhere, of course, the first thing comes in our mind about health is hospitals. And then we have healthcare centers, and we can also have the companies or inside the universities or somewhere else, right? Okay, so these are the possible applications of using M-health concepts. For example, we can attach thermometer, pedometer, heart rate straw, insulin pump. They already have been introduced in the market, glucometer, other things. So by utilizing these things, we can have a body area, a component of body area network, which can ensure that to provide a mobile health. And after getting the readings, because all these things are attached physically with your body, so we can get some readings in terms of analog or in terms of digital form. So we need such kind of protocol, or we need such efforts, because our body cannot give us the digital values, right? Even if the sensor is attached, it will just collect the analog value. So we need some protocol, we need some applications which can have the capability to use those analog information in digital form, and then just to provide the useful data for a better human understanding. Well, this is just one slide to show that after reviewing several papers and after reviewing several applications in actual, I found that only 30% is the development and 70% is just the research. So which means that there is a huge trade-off. At least it should be in opposite direction, because we need deployment. We need some real-time applications rather than just proposing some effort or some protocols. We need some real deployment here. So this is a ratio of, in terms of body area networks, still 70% results are by simulators but not in real. So we need to think about this issue as well. Okay, when we talk about the protocol, which protocol we have used in this application, so basically this protocol works with top 3 layers of the network model: presentation, session, and application. And we have, within this protocol, we have an important component which is called as MDER. It stands for Medical Data Encoder Rule. Why we need MDER is this is a set of rules defined to organize that analog data which we're going to receive from a sensor into a digital format. And we're going to use it, I'm going to show you in the next upcoming slides that how we're going to use this MDER. And this is for the medical devices equipped with sensors. All those devices which are equipped with sensors. And they are capable of communicating. So for that we need this set of rules. Then also the best thing about this protocol is that it has a support for session layer, even if physical and transport layers are disconnected, because it can be any reason, because of the power cutoff or any reason. If the transport or physical layers are disconnected, still the session layer will hold some data in order to transmit it after the re-establishment or reconnection. And then it also supports the Bluetooth. So why we use Bluetooth, I will also explain in the coming slides. Okay, for this experiment which we performed, the smallest measurement, we used, actually according to the protocol, there should be one agent and there should be one manager. So basically agent is a device or a concept which is going to replace human for collecting data. Conventionally, a human should come and it should place something on your hand to check your heartbeat rate and pump something or anything like that. But we need another human to do that. But here, it's not going to happen. The agent is going to collect data. How it's going to collect data, you will see in the clip. And then we have personal health device. We also call agent as a personal health device. But it has a constrained memory, which means it has a very low memory for calculation and for computation, right? And then DIM applied. That's one of the modules within the how can I say, protocol. It's going to apply on both sides, and I will tell you why. Then on manager side, manager can be your, in our case, the experiments which we performed, there was an Android handphone of Motorola X series having 4.04 version of Android. So it can be a handheld device, just like your cell phone, just like a tablet or anything. And then we have, because cell phones and those devices are fast computing devices, so we have no constraints regarding computation. So it means that according to the protocol, we should put a computation burden a lot on manager side, not on the agent side, because agent is also getting the analog values and just converting those values into digital form. That's it. So, and here we also have a DIM applied. The reason, what is DIM? These are the set of rules which should be applied on the both sides. An agent is going to attach with the body of patient and it's going to transmit some data. But that data will be in a hexadecimal format. So we need to translate that format for a human understanding format. But okay, what this value means? Is it critical? Is it normal? Or is it below the average? So for those reasons, we need DIM, and for every device, there will be a separate DIM. It's for now we just use the heartbeat rate, so we use that DIM. But for every device, we have a different reading module. Okay, so before explaining the overview, this was the expected output that we should have. We have off-body sensors included in that agent, which are going to be connected via Bluetooth with the device, with the Android device, when they will be in a Bluetooth range. And then, of course, that device will be a cell phone. So after receiving via Bluetooth, we can do whatever we want. We can use GPRS, we can use LTE, whatever is the low cost, and we can just send them back to the servers for further applications or whatever the use we would like to have. So